Alright, so to start this lesson, I kind of want to throw some formulas at you guys, and a lot of them should be review, right? So the first one, the probability for finding the probability of one event or another event. And so what that means is, what's the probability of A union B? In other words, what's the probability of A happening or B happening? And you guys saw this when you read the packets. This is the probability of A plus the probability of B minus the probability of A intersect B. In other words, A and B. Okay? So there it is, right? So if you have one event or another event, that formula will work. And something that's neat about this formula, that formula always applies. Like, it doesn't matter what kinds of things you have, that formula will apply. The next two, you'll notice from one of the comments I have over here, they're different. One of them is for dependent events, and that's, you guys have already seen it. When I say two events, I basically mean an AND probability. If you want the probability of A and B, it's the probability of A times the probability of B given that A has happened, because they're dependent events. By the way, you can also write it as the probability of B times the probability of A given B. The important part is that you have one of them that's an A and one that's a B. So one that's a B, one that's an A. Okay? When you have independent events, and this is sort of the new thing for today, the probability of A intersect B is the probability of A times the probability of B. And I've talked before about this. I have a hard time teaching probability because so much of it is to me is just like you kind of get it or you don't, and I don't want to be negative about that, but it's sort of like I don't like using formulas. I like teaching this stuff as concept. And so one of the concepts I want to show you is right here. When you have an OR probability, in general, you'll notice that we are adding things together. You want the probability of one thing or another thing happening, take the first one and add the second one. Maybe you have to subtract off the intersection, but the concept is you're adding. Look at both of these below that are about AND probabilities. This one, the probability of A and B, is A times B given A. This one down here is A times B. When you're doing AND events, we tend to be multiplying. When we are doing OR events, we tend to be adding. So I sort of want to say, as you guys are working through these problems, try to gain some intuition for them and get an understanding for whether your problems are OR or whether they're AND problems. Okay? And if nothing else, this is what we have. One more thing I need to say about this slide is that this right here is basically a test for independence. So what does it mean if two events are independent? Well, it means that their probabilities don't depend on one another. But if you're only given numbers, you won't know if they're independent. The way that we know if things are independent is by doing this test. Is the AND probability equal to the probability of the first one times the probability of the second one? And so I want to get into an example of that next. So right here, if the probability of A is 0.6 and the probability of B is 0.5 and the probability of A union B is 0.8, determine if these two events are independent. Okay, so this problem says determine if they are independent. In other words, I don't know that they're independent, right? I can't just say, oh, well, I'll do A times B to figure this out. We're going to have to find some other way to figure out what the AND probability is. And if you're up for it, I'd say pause the video and think about it. Think about how you can use all three of these values to do that. Well, hopefully you recognize, well, hey, wait a minute. We have a formula that lets us work with the probability of A union B. It's supposed to be the probability of A plus the probability of B minus the probability of A intersect B. And so I could just plug things into this and solve. 0.8 is equal to 0.6 plus 0.5 minus this unknown AND probability. If I add these two things together and move it over, you'll end up with negative 0.3 equals negative probability of A intersect B. In other words, the probability of the intersection is 0.3. Now the question is, does this mean that they are independent? Well, how do we test for independence? If they're independent, the probability of A intersect B will be the probability of A times the probability of B. So what is 0.6, which we were given, times 0.5? Turns out it's 0.3. Since I got the same answer both ways, it means that A and B are independent. Okay, so this is a somewhat simple question. I mean, it's a basic thing. If you want to know if things are independent, find their AND probability, and find out if it's the same as the product of the two probabilities. So this was a problem that was dealing with independence, where we didn't know what the events were. You just had numbers. Right? In the next problem, it's going to be sort of a word problem, which means we're going to know about the events. Okay, so let's look at that next. So let's say a classroom has two computers. Right? There's a new one and an old one. The new one has a 90% chance to be able to access the internet on any given day, and the old one has only a 70% chance of connecting to the internet. Okay? Are those two things independent of one another? And I just sort of realized, maybe it seems like they're not because, the internet, the connection from the school might just be down on a certain day. I was looking at this being that they are independent, that, one of the computers is just finicky, and if you guys have been in class with the iPads, you've seen that happen. Like some days one of them will connect and one of them won't. I'm going to assume that these two events are independent. I don't know if this is the best example, but we're going to start with the idea that these are independent. Right? So for question A, this first one here, find the probability that they are both connected to the internet. Right? So how am I going to find the probability that both the new one and the old one are both connected to the internet? Well, if these really are independent events, then I can do the probability of the new one times the probability of the old one. That would be 0.9 times 0.7, which is 0.63. So there's a 63% chance that both of them will actually connect on a given day. Right? What about the second one? What's the probability that they're both not connected? I'd really like you guys to pause the video, try this one out, see if you can see that on your own. Notationally, this would be the probability of not the new one and the probability of... I should just erase that. And the probability of not the old one. Well, that's supposed to be the probability of not the new one times the probability of not the old one. What are those two probabilities? Well, one of them is 0.1. That's 1 minus 0.9. And the other one is 0.3 because it's 1 minus 0.7. So probably that they're both not working is only 3%. Okay. Then in the final question, right, this C, find the probability that at least one of them is connected. And this is probably the most important question. Right? The probability that at least one is connected. In the book, if you read it, the book actually talked about when they use the words at least or at most, often you're supposed to use the complement, right? What is the opposite of at least one is working? The opposite of at least one working would be the probability that none are working. And if that doesn't make sense, you I'd really, really, really recommend you pause the video and think about that right now. The probability that at least one of them working means that one of them is working or the other one is working. Or maybe both of them. The opposite of that is that none of them are working. But what's cool is we just did that probability. We found that the probability that neither one of them was working was 0.3. So for this computation here, I can just do 1 minus 0.3 that we figured out before, which makes the answer to this 97%. The probability that at least one of them is working is 97%. So at the end of this video, the takeaway is basically, when you have independent events, you can just multiply their probabilities together to figure out what the probability of both of them happening is. So I'll see you in the next video.